Okay, so in video 4E I did some vector addition and based off of a lab, and we're going to do basically the same exact thing with a different situation. This is based off of 4F, where I had a paint can that was going down, and my paint can was 4.6 kilograms, and then I had a 72-degree angle between two strings, and I had 30 newtons in that string and 30 newtons in that string. Okay, well now we haven't really done this yet, but we need to convert 4.6 kilograms into, that's a mass. Right now we need to make that into a weight. So weight equals mass times 9.81 meters per second squared. So you just multiply by the acceleration due to gravity to convert a mass into a weight. And so my weight is going to be 4.6 kilograms times 9.81 meters per second squared. And I'm going to get 45, we'll call it 45 newtons. So, we know that this is pulling down with 45 newtons, and we had two strings pulling up at 30 newtons each. And what I'm going to do is I'm going to say that there's a vertical line here, and each of these is 36 degrees off of the vertical. Okay, and I think I'm actually going to just jump right down to, we could plot this on this paper, and in your lab, if you're going to do this on the lab, you should plot it on this paper, and you should do it for like 4 different angles. What I really want you to, if you want this graph paper, just Google You don't have to buy graph paper in a store. You can just download it off the internet and print it out on your printer. So this is polar graph paper. Okay, so we're going to use regular old graph paper to graph this right here. And I'm going to need a little bit of regular graph paper, so 1 second while I get it. So let's figure out, I can use a scale. My biggest vector is 45 newtons. So the scale that I'm going to use is I'm going to divide that by 3. So I'm going to say that that's 15 centimeters. And this is 10 centimeters. And this is 10 centimeters. Okay. So, adding vectors tip to tail. First thing I'm going to do is I am going to, let's see, can I get away with doing it this way? Just barely. Okay, so I'll do it this way. I'm going to measure 15 centimeters. And it's going to go from there to there. And so that is 45 newtons, otherwise known as 15 centimeters. In newtons, that is the weight of the rusty bucket of paint. Now, I'm going to have a vector that comes 36 degrees off of that. So I'm going to come over here. I'm going to measure 36 degrees out here, and that's going to be one of my strings. And so one of my strings is going to go in that direction, and it is going to go 10 centimeters, otherwise known as 30 newtons. Right to about there. So that is going to be 30 newtons, otherwise known as 10 centimeters. And just lucky enough, I kind of end up on a vertical. And so my other vector is going to come back at 36 degrees the other way. So it's going to be 36 degrees off a vertical the other way, which is going to be right there. And I'm going to go 10 centimeters in that direction. Okay. So that is going to be another 30 newtons, otherwise known as 10 centimeters. And once again, just like video 4E, in this video we find that the rusty bucket of paint was not going anywhere. So since the rusty bucket of paint was not going anywhere, the total force should be 0. So when I take the force due to gravity on that bucket plus the force of one of the strings plus the force of the other string, those three forces should add up to 0. Because they came very, very close to each other, I'm going to call this a success. So this is my experimental error right there. And I'm going to say that that little gap is due to the fact that there's errors in that when I took this measurement of 45 newtons, there's an error there. There's an error there. There's an error there. There's an error in this angle and that angle. In the measurements that I took in the lab, there's 5 measurements that have error associated with them. Then when I plotted that data, did I make this exactly right? Did I make that 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 exactly right? No. So in total, there are 10 places where I could have made slight mistakes in how I measured it or how I drew it. And so when you add up those 10 mistakes, what you end up with is that little gap right there. Okay, so that is that lecture on adding vectors, and I think that we are going to come back with a different topic in my next lecture.